So, good evening, and welcome back to yet another video. Um, I have this power meter, or it can actually show a lot more than just the power. It shows power factor, power usage, um, amps, and a bit other type of information. Anyway, and yes, I'm sorry for the voice. I'm having a cold, so that my throat isn't the best. The zest of life. Anyway, so um, yeah, I have noticed that this power meter isn't actually working that well anymore. It has been sporadically working sometimes, and sometimes it just puts zeros on the display. So I thought we could take it apart and see if it's something we can fix. Since this was actually something I figured out after I had bought this one, which is yet another Chinese LED floodlight thing, and I was about to do the power factor and see what type of electronics, and also if it is a true 10-watt floodlight. But since the power meter doesn't work, need to start with that. So let's take it apart. And that throat thing, I have noticed an interesting thing with when you have a sore throat. It feels uncomfortable, of course, and I have found that Pepsi Max seems to soothe it, at least for me. And it also gives me an excuse to drink it, since I like it so much. Just don't try to blend it with rum. It doesn't taste very well. I don't know if it's the artificial sweeteners or if it is something else, but rum and Pepsi Max isn't a very good combination. Let's see if I can find something to open this with. There we go, some backup power, I guess. Let's see if we can pry this one open. This is the part where I stab myself badly, I would imagine. Oh, it has some tabs to holding it. And there we go. So, what do we found? What do we find in here? Guess we have the amperage bridge or something like that. And inrush capacitor and discharge resistor. And this is the display. But it has some buttons here, and I'll reset, and then tactile push button, don't know what it is. But let's dig further and see if we can find something that looks suspicious, something that looks like it could be broken. But I think we need to take this board out first, so let's start with that. And this is the most exciting part with these types of videos, I know, to watch someone else unscrew things, and everyone knows how to do this. And I know that people aren't really liking this, but in the same time, I'm too lazy to edit this part out. It gives us a time to just talk about something else, like the dog, my dog, that is in here, walking around, messing the sound up. You can hear his paws everywhere. Anyway, so let's take this apart and see. Can we? That doesn't really matter since we can't remove this. No, let's just remove this. Let's see what's what on the other side. Okay. There is some components. From the top of my head, I see that this one is called a 78L05, and I know for a fact that this is a 5-volt linear regulator, and I guess it is providing these two chips with its power. Here we have the full bridge rectifier circuit. There's two diodes, each in every direction, and some small capacitors on the other side just to smooth that wave out a bit when it comes through, and then to this regulator. This is a, I mean, I can't see what's in there, or can I? It's a something or other. I don't know. But since it is coupled with the ribbon cable to the display, I would guess that it's just the display driver. We can also see that this ribbon cable has some printing down on the circuit board where it says whatever thing is. I have noticed, well, now when I'm looking at it, everything is kind of marked what it is. Well, this one is just called the U4, and this one is called, I don't know, U2 or something other. But the 5-volt regulator has its markings also silk screened on the chip. That's quite nice. If this would break, I mean, if the display wouldn't come on, I mean, a few components could have gone wrong, but a good bet would be this 5-volt regulator. So if it is broken and it can't supply these chips with power, then the thing wouldn't work. So that's an easy. It's also an easy component to change, actually. The other thing here is called a Serious Logic CS5460CISZ, and I have come across one of these before in a previous, on another power meter, and this is actually a dedicated power meter logic chip, and it's both used in these domestic power meters, but also in more industrial applications, since that can be used in power supplies as feedback for the power supply to know what power factor it's holding, and things like that. And you want to have a good power factor in your machines. And the power factor is something that actually is becoming more and more relevant, since it's the difference between, and let's see if I can remember this, the true power and the perceived power usage of something. And the electric companies, at least here in Sweden, are measuring the predicted power usage, which is actually what the power meter shows, but it isn't actually the true power. The true power is something more closely coupled to the power factor of different machines. And the power meters in our houses and homes here doesn't take in consideration the power factor. So, and the power factor is, it's a ratio from 0 to 1, where 1 is when you have a sinusoidal waveform, like the sinus wave that we have in our outlets, 50 or 60 hertz, depending on where in the world you're situated. That's the fluctuation of the voltage in your power lines. And the power factor is how much the amperage or the current is lagging behind the voltage. So then you can have, let's see if I have, don't I have something to draw on? I had that once here. Let's see if I can find something to draw on. Just one moment. There we go. Here we have something to draw on. Okay, so the power factor, if we have a sinus wave, time like that, then we have a sinus wave that goes like so. So this is some hertz, for instance 50, and that's the frequency which the polarities change in your power lines, like so. And this gives us our AC, or alternating current, switching current. And the power factor is how far behind this power curve, or voltage curve. This is the voltage, yeah. And the power factor is how much the current is lagging behind this current, this voltage. So this is the power factor, the difference between these two lines, these two curves. And if it is just a fraction off, then it's quite okay. A power factor of 1 is the best, and that's when the power, the amperage or current and voltage, current and voltage are following each other perfectly. And 0 power factor is when these are totally out of sync. So that would be something like, let's see, like this. They're 180 degrees out of sync with each other, something like that. So that would be the worst case scenario. And it's a good example to show how efficient or how well built a power supply is. Mostly, that's something. And these LED drivers have 2 different types, and we will get into that when we open this one up later on. But that's the power factor. And this little chip here can measure the difference in voltage and amperage, and then calculate the power factor and show us how close these two are together. And the closer these two are together, the better the better power factor you have on your equipment. But still, this one isn't working as it is right now, so we need to figure that out. I have actually seen something. I don't know if it's come through on the camera or not, but if I do like this, can you see that this seems to be loose? Yeah, that's one of the capacitors on the other side. And I bet if we solder this one on, this will actually function. So I will try to do that momentarily. There we go. And the solder joint is made with this thing. So now it's just a matter of putting it back together and then see if it works. And there we go! Fully assembled. And I haven't cheated, I haven't stopped the camera for this test, so let's see if this works or if it'll emit the magic blue smoke. Oh. Display comes on. It's always a good thing. Let's see if the display actually ever comes out. Goes out. It says 50 Hertz. And it says 228 volts, which is kind of close to what the 230 we have or 220 we have here in Sweden. This hasn't worked for a while, so I think that solder joint was the thing that made this bad thing happen. Let's see if it can show that power factor I was talking about. So I'll plug in this lamp and let's change the function to amps. It draws 100 milliamps, seems about right, and it uses 22 watts, which is a lot, since it is $22 watts for a 10-watt lamp. I wonder where it dissipates the other 10 watts. And there you also can see what I talking about, the power factor. And the power factor for this one, well, it goes from 0 to 100, but it's 0 to 1. It's 9.6 or 96 in power factor, which is really good and tells me there is a proper switching power supply inside of this instead of what's it called? Well, when you use a resistor and a capacitor, whatever. Someone will type it down in the doobly. And that's about it. But it works again. Great! Then we have actually fixed something instead of just breaking stuff, which seems to be the default value. And here you can see when you draw no current, it says power factor is 100 or 1, which is a lie. So, well, I think that's all for this time. And well, as always, thank you for watching, and have a nice day. Bye bye!